Welcome to the Rotary Earth Network Club with Earth Talks. We have a few things just to let everyone know. We want to thank our members, associates, donors, and volunteers. And if you haven't already joined Earth Talks as an associate member or a member, please consider joining us. Please mute your audio when not speaking and feel free to turn off your camera to reduce the carbon footprint when we're not like in a chatting mode. So, like when Emily's presenting. Recordings and resources are available on the Earth Talks Foundation website. Just go to earthtalksfoundation.org. And, we always have to say this speaker views are their own, and some features are limited for our safety. So if you need to share screen or something like that, just uh, text or chat with one of the co-hosts, and we can let that happen. All right. Now for our four-way test.
Okay, I'm going to read some of this. So, the rotary four-way test.
Of the things we think, say, or do,
First, is it the truth?
is the environmental information accurate, science-based, and transparent?
Second, is it fair to all concerned?
Does it protect people, ecosystems, and future generations?
Third, will it build goodwill and better friendships?
Does it encourage collaboration, shared responsibility, and community trust?
And fourth, will it be beneficial to all concerned?
Does it improve environmental health, human well-being, and long-term sustainability?
Thank you both. And if you're new to Earth Talks, I just wanted to let you know that if English is your second language, or if you're a little bit hard of hearing like me, whether you're on your phone or your laptop, you can simply go to your settings and hit closed captions. Choose the language that you want to hear, and you can see closed captions at the bottom. And now, let me close out of this one. And we're so happy to have Emily Stevenson with us. Just delighted. And Claudia, will you please introduce Emily?
Hello, everybody. Um, I read some about Emily and I know something about her, but I think she's the best one who can talk about herself and what she does. But I met her about 5 years ago when I was responsible for our district, which was working with Ant Plastic Soup, and we did a wonderful interview with her. And this is why I know her. And from then on, I'm looking at everything she does because it's always posted on Facebook. So I'm happy to have you here, and I know you have to tell us a lot. Thank you very much.
Oh, that's lovely. Thank you so much. It's lovely to see you again, Claudia, and it's fantastic to be here. So I'll crack on. Hi everybody. My name is Dr. Emily Stevenson and I'm a marine microbiologist. I'm currently in the UK, but most of the time at the moment I'm based in Australia where I'm working as a scientist exploring chemical pollution in the environment. But I wear lots of different hats and I do lots of different jobs. So I'm just going to share my screen and tell you about some of the things that I get up to. I think a few people might still have their sound on, so if we can all just mute ourselves, that would be fantastic. There's a little bit of feedback coming through. Sure. Okay, can you see my slides okay? Fantastic. So, you might be thinking, what's this on the screen now? Beach Guardian. This is the organization that I co-founded in 2017 alongside my dad. And this is one of the main hats that I get to wear as the co-founder of this organization. And Beach Guardian aims to engage, educate, and empower against plastic pollution. That is my goal. My life mission is to tackle plastic pollution in the environment. And what everything I do surrounds. It's all about plastic pollution for me. So Beach Guardian is a social enterprise predominantly based in Cornwall in southwest England, but we have collaborators and volunteers all around the world, all working collectively to empower people to tackle plastic pollution. So, what do we actually do at Beach Guardian? Well, the work that we do can be divided into lots of different areas. The first is we work within the community and we work collaboratively with lots and lots of different people. And one of the main ways that we work within the community is doing outreach events and beach cleans and litter picks and getting people out into the environment. That grassroots action of getting people actually outdoors on the front line tackling plastic pollution. But then, of course, you can't just do beach cleans and litter picks without providing education because knowledge is what empowers people, really. It's what inspires people to do more because once you know better, you can do better. So we have an established education program, which we've successfully delivered to every primary school here in Cornwall, and lots of other places around the world to make sure we're educating people about plastic pollution so that people feel informed enough to tackle it. And I'm going to go into a bit more detail throughout my talk about all the different things that we do within these sort of categories. But the third area that we work in is working with businesses. And we don't do this in an activisty way. It's not about me going and gluing my body to a plastic manufacturer until they stop producing plastic. I think that activism has its place, but it's more about sitting down at the table with these people and finding solutions together. So we work with lots of different businesses all around the world, mostly to help find alternatives to unnecessary uses of plastics. And we also work within policy. So we have that sort of bottom up action, that grassroots action, working within the community, but also that top down support as well through legislation and regulation in the UK, but also internationally as well. So, a few years ago, I worked at the UK House of Lords to look at what the UK government was doing to tackle environmental pollution. But as well as that, I've also worked within the G7. So I was part of the official youth engagement group for the G7, looking at how the G7 nations could also tackle environmental pollution as well. And we do lots of things to help develop better policies to regulate and monitor environmental pollution better than what we currently are. Now, healthcare is not something I ever really saw myself working in, and I introduced myself as doctor. I'm not a medical doctor, so if someone was injured in front of me, there's not really a lot I can do. So I'm not that kind of healthcare professional. The doctor is, I'm an environmental scientist, and that comes in later. But we work within healthcare because of something called social prescribing. I don't know if anybody's heard of that before, but traditionally, if you're suffering with your mental health, you might go to your GP or your doctor and you may be prescribed antidepressant medication. And whilst this works for many people, other people, these sort of manufactured medicines don't really work. And what does actually work is social prescribing, where you might be prescribed to volunteer or join your community or be reintroduced into your community or connect with nature and that kind of thing. And it's sort of a practical way of giving you a sense of purpose and control over your life. So we actually work with our local healthcare provider so that people can who are suffering with their mental health or loneliness or addiction can come and join us on our beach cleans. And we've seen remarkable success of people feeling better and regaining that sense of purpose and passion in their life just from doing a beach clean. So that's something amazing that we're able to do, is harness the power of nature for human well-being as well as ecosystem well-being. And then finally, the final area that we work in is research. So we do all of these things, but we have to have some idea of what we're talking about. So I'm an academic, I'm a scientist. I studied marine biology for my first degree, and then I had had enough of academia after my first degree, and I thought, that's it, I'm not doing that anymore. That's when I started Beach Guardian to keep me busy after I finished my degree. And then I was like, oh, I think I'm going to have to go back to academia because I need to learn some more. So I did my master's in conservation science and policy. And then I thought, well, actually, I quite like this. And I've just I finished my PhD last year. So I'm going to tell you a little bit about my research first, what I've been exploring for my PhD, and that's why I'm now a doctor, as I said, environmental scientist, not human doctor. So my research is all about microplastics. And you've probably heard of microplastics before, but for those of you that haven't ever heard of microplastics, these are smaller pieces of plastic. They're actually any plastic less than 5 millimeters in size. So half a centimeter and below, that's all microplastics. And whilst they may be small in size, they are absolutely not small in quantity. It's estimated that up to over 100 trillion microplastics have already accumulated in aquatic environments. So there's vast quantities of microplastics already in the environment. And we know that they lots of risks are associated with microplastics. So they get ingested by marine species, and we know that microplastics are in human blood and human brains and breast milk and placenta. We know it's getting in our bodies, but we don't actually know what harm it might be causing because the research is in so much infancy at the moment. Um, but my research really looked at the human health risks of microplastics. And I took this photograph. Well, I didn't take it. Somebody took this photograph, that's my hand, before I started my research. And now every time I see it, I think, oh, I really wish I was wearing gloves. And you're about to find out why. So microplastics are small pieces of plastic. And I actually research microplastics and bacteria. So on the screen here, I love this photo, it's quite beautiful. These are lots of different colonies of bacteria. And what you're seeing on the screen there is derived from a sample of water here in southwest England. And those dark blue or purple colonies, they're all E. coli. You might have heard of E. coli before. So bacteria, when people hear bacteria, they often think, oh, scary, that makes us sick. But it's really, really important. Bacteria is so essential. And really, in the human body, we have more bacterial cells in our body than we do human cells. And they are so essential to our whole system functioning in our gut, but also, everywhere in our body, we have harmless bacteria helping us to survive. But then, of course, you do have those pathogenic bacteria, disease-causing bacteria that can make you sick. And of course, bacteria isn't just important in the human body or the body of animals, but it's also everywhere in the environment. Bacteria is literally everywhere. In 1 litre of seawater, you can have billions of bacterial cells. And what's really interesting is that traditionally, if you have a pathogenic infection, you would treat it with an antibiotic and the infection would clear. That antibiotic would successfully treat that infection. But now we have this problem of antimicrobial resistance. And you might be thinking, how have we got here? We're talking about plastics, and I'm going to tell you how it's all linked. But antimicrobial resistance is where bacteria evolve the ability to survive and persist and grow in the presence of an antibiotic. And this really demonstrates that quite nicely. So on the screen here are two agar plates, what we call agar plates, and they're Petri dishes filled with this type of jelly called agar. And this jelly has all of the nutrients in that a bacteria would need to grow. So on those agar plates, that snotty slime, that's all bacteria. And those white dots, they're all antibiotics. So on the left-hand side, you can see that around all of those white dots, there's no snotty slime. So that means all those antibiotics have killed that bacteria. They're working successfully. But on the right-hand side, you can see that several of those antibiotics aren't working anymore or are working less efficiently. And that is because the bacteria has evolved this capacity to survive antibiotic treatment. And this is one of the greatest threats to modern medicine. It's predicted that by 2050, more people will die from an antimicrobial resistant infection than they will cancer. This really is an emerging threat to human and modern medicine, really. You know, you think, how many times in your life have you taken antibiotics for a UTI or a stomach infection or something, and you've been perfectly fine afterwards? But what if that antibiotic hadn't worked and you weren't fine? And that's what we're facing, is these illnesses that were once easy to treat are now killing people. So now we're going to look at how microplastics, bacteria, and antimicrobial resistance are all linking, because I'm sure you're sat there thinking, well, where is the link? So as I said, these are the antibiotics that are failing. So to understand the link between these three things, you have to think about how plastics are getting into the environment. And there are lots of different sources of plastics going into the environment. But what's really interesting is that those sources of plastics massively overlap with the sources of antibiotics. So I've marked with X's on the screen there where you see antibiotics going into the environment, because what happens is when a person eats an antibiotic, or takes an antibiotic drug, I should say, the body doesn't fully break it down, meaning that antibiotic comes out in our wee and our poo, and then it will go into a wastewater treatment plant and make its way into the environment. Meaning in lots of environments, you've got microplastics or other plastics and antibiotics all in the same environment. And when you have an antibiotic, natural selection will take place, meaning the only bacteria that will survive are those that are already resistant to antibiotics, and they will spread and proliferate. So, what we also have in those environments are microplastics, antibiotics, and lots of other co-contaminants and bacteria all growing together. And what my research is focusing on is the plastosphere. So when microplastics go into the environment, they're very, very quickly colonized by bacteria and what we call biofilms. Now, you've probably seen biofilms before. Sometimes, you know, if you haven't brushed your teeth for a while and you get that plaque filming on your teeth, that's a biofilm. It's just bacteria living really, really closely together, and they're encapsulated in slime. When microplastics are in the environment, those bacteria form on them in this slimy sort of community. And what happens is, because they're living so close together, they can pass genetic information, meaning bacteria on microplastics are more likely to be antimicrobial resistant. And because there's so many microplastics in the environment and they travel all around the world, they can carry with them bacteria or bacteria that could be resistant to an antibiotic. And what we're really interested in understanding is whether if you are exposed to a microplastic that has an antimicrobial resistant biofilm, would you get sick? And are you going to be unable to treat that infection with antibiotics? And just to show you some pictures that I took during my PhD, this on screen now is a microplastic. So it's obviously not to scale. Just think this will be about 5 millimeters in diameter. And you can see the actual plastic is grey. So anything that isn't grey is a microbe. So of course you can't really see bacteria with the human eye, but what you can see here, this is all fungus. So it's not just bacteria, but it's fungi as well, growing on microplastics. And I like to think of this, the plastosphere, the reefs attached to microplastics, as tiny little microbial reefs, incredibly diverse. You've got so much going on just these tiny particles floating around on the ocean. And if you look really, really closely, as I was saying, when bacteria are in biofilms, they're able to pass genetic information. So all of those bacteria are talking to each other and they're saying, oh, well, they're obviously not saying they don't talk, but they use chemical cues to engage with one another. And if one bacteria has a gene that makes it able to survive an antibiotic, it can pass it to another bacteria. So you've got these super bugs enriched on microplastics. So that's a summary of my research. And if you'd like to learn more, I can send some of my published research for you to read about. Essentially, what I'm doing with it at the moment is researching to understand which plastics are the worst in terms of, well, do worse bugs, more disease-causing bugs or more drug-resistant bugs prefer a certain plastic polymer over others. So we can't say stop using plastic altogether, but we could maybe say, well, this plastic, those bad bacteria really, really love. So if you touch it, you wash your hands, and we should really stop using certain types of plastics. That's what I'm doing at the minute. But anyway, I wanted to move on from my research because that's enough of the hardcore stuff. I see a hand's come up. Do you want to jump in quickly here with the question before I move on?
No, at the end.
Okay. So I'll move on and then we'll do questions at the end of my talk. But as I said, I'm going to move on from my research and sorry, there's a little bit of feedback. Can we just all make sure that we're on mute, please? And I'm going to talk to you a bit more about what we do at Beach Guardian to focus more back on the community side of things. So, where did Beach Guardian actually begin? But we have to go all the way back to when I was a young woman growing up in Cornwall, southwest England, and I was very, very lucky to grow up here, spending all of my free time on the beach. And when I was in school, it was in art class, I was told, the teacher told the class that we needed to go down to the beach to pick up natural items so that we could make a sculpture out of them. So we would collect seaweed and shells and sand. And I went down to the beach, and this is 18 years ago now. And I was finding plastic. And I thought, I'm going to take this in and use this for my art project. And I loved it. I thought it was really cool that I had all of this material free of charge on the beach waiting for me. So I started a website called cornwallbeachcombers.co.uk. And the purpose of this website was for me to go and collect plastic from the beach and sell it so that other people could use it as a resource. And all of the money that I raised, I was donating to the Marine Conservation Society. And it was there 18 years ago that I decided I'm going to be a marine biologist and I am going to tackle plastic pollution. And this website is still live on the internet. It is real, but of course, I'm not selling plastic through it anymore. So let's fast forward to what Beach Guardian looks like now. And as I said, we do a lot of beach cleans. We spend a lot of time actually in the environment picking up this waste. But what we like to do at Beach Guardian is something a little bit different because most people, or a lot of people, are doing litter picks now and picking up plastic. But when we first started Beach Guardian in 2017, we very quickly realized that there was a lot of this stuff to collect, and it didn't feel right to just take the plastic off the beach and put it in a bin because we had no idea where it was going. So we decided that we would keep, collect, clean, and sort the plastic that we were finding. And when you clean it up a bit and sort it into colours, you've got this really wonderful resource that you can actually do something with. So we're really fortunate to have a space called the Beach Guardian Lab, where we take plastic off the beach and we store it here, where we are then able to clean and sort it. And just to give you an idea of the scale of the amount of plastic we collect, each of those blue bags is one beach clean. So you can see there's absolutely hundreds here, and this is just a small portion of our collection. We have so much plastic waste. And sometimes when I look at this picture, I feel a little bit hopeless because I'm like, oh my goodness, look how much waste was in the environment, polluting the environment. But actually, let's reframe this. This is difference that a community can make when they come together to tackle plastic waste. But obviously, taking it off a beach and putting it in a pile isn't really finding a use for the plastic. So some of the workshops that we do is with school children. They come and visit our lab and we can create small pieces of artwork to sort of change that wasteful mindset in young people of what was waste is now a resource, introducing the concepts of the circular economy, how we can keep using materials after traditionally they had been wasted and turn them into something that we can be proud of. And some of the things they make are quite sweet, but of course we can't turn all of the plastic in the ocean into little pieces of art like this. So I'm going to tell you one of my favourite stories now. I'm sorry, it's not Rotary, it is the WI, but it's a brilliant story all the same. So just to sort of exemplify that at Beach Guardian, we want to work with everybody. We were contacted by our local WI group, the Women's Institute, and they said, oh, Emily, we see what you're doing with Beach Guardian and all of the beach cleans that you're doing, and we really want to get involved, but some of us have accessibility issues. We can't get down to the beach. How can we be involved? And I said, well, what's your favourite kind of workshop that you do? What's your favourite event at the WI? And they said, well, we love our knit and natter coffee morning, where we get together, we do some knitting, and we have a chat, and we drink some coffee, and it's lovely. And I said, okay, well, we find lots of ghost fishing gear washing up on the beach, as you can see from this picture. And you call lost or discarded fishing gear ghost fishing gear because it keeps catching wildlife, even though there's not a fisherman on the end of it anymore. If it's lost or discarded in the ocean, it floats around like a ghost. So I said, we've got this ghost fishing gear, but it's all tangled up we can't do anything with it when it's tangled up. So I want you to do the reverse of knitting. I want you to untangle these horrible balls of yarn and turn them into a resource for us. And we'll call it a knot and natter coffee morning. So they agreed to it, and they were a bit uncertain at first. So I dumped these two balls of rope on their driveway. And when I first arrived, excuse me, they were all sat inside in that dark hall, just sort of sitting there. And I said, give me a call in an hour and I can come and, you can stop and I'll come and collect whatever you've done. Anyway, they called me an hour later and they said, actually, Emily, uh, we're really enjoying ourselves here and we'd like to keep going. And we'll call you when we're done. They called me 8 hours later and they said, Emily, we've done the lot. And I saw these pictures. They sent me some pictures afterwards. And look at these women. They are smiling. They're outside. They're connecting with each other. They're in the sunshine. And they were once sat in a room. And now they're dragging chairs out on their hands and knees, uncoiling or recoiling this rope around chairs and everything. It was amazing to see the difference that it made. And then I've got a resource. I can actually use these nets and ropes for other things. And of course, we can use them for small art projects like these little sustainable willow fish that we produce, but also we can turn it into something else. So we created an 8-meter long humpback whale out of ghost fishing gear that we found on our beaches that the WI sorted out for us. And this is amazing, it was invited to the premiere of the Seaspiracy documentary, and that meant that I was able to join a global panel of activists talking about plastic pollution. But also, our 8-meter long humpback whale met Boris Johnson, who was our Prime Minister at the time. And our whale has even been to Glastonbury Festival, spreading awareness about plastic pollution. So, something that we've found is really powerful is to be creative with the ways that we talk about plastic waste. You have to get people to connect with this problem. And one problem that is particularly persistent that I'm a bit obsessed with are crisp packets or chip packets. These are single use, they're not easily recycled, but the best thing about a crisp packet is that they all have dates on them. So if you find a crisp packet in the environment, you know how long it's been there. And the oldest crisp packet I've ever found was from 1966, which is the year that my mum was born. So these crisp packets look like the day that they were made. So I wanted to raise awareness about crisp packets. I'm obsessed with crisp packets. But I thought, how is a young person like me? I was young at the time. I don't feel very young anymore. But how is a young woman from Cornwall going to get the attention of a crisp manufacturer? So I decided to get inventive. And that was when I decided to produce this dress that I made out of crisp packets. And I wore it to my graduation from my marine biology degree in 2018. And it did exactly what I needed it to do. Walker's, who's owned by PepsiCo, which is the second largest food and drink manufacturer in the world, knew who I was. And they contacted me and they said, okay, Emily, by the year 2025, which was last year, we will make 100% of our crisp packets recyclable, compostable, or biodegradable. And at the time, remember this is in 2018, I said, okay, but by then you'll have produced 28 billion more packets of crisps. What are you going to do to stop those packets ending up on my beaches. So I had some fantastic opportunities to go live on Sky News, BBC, and you can see this woman in the top right corner. She's holding a crisp packet there from 1997, the year that I was born. And the gentleman in the middle, that crisp packet he's holding is from 1985. So you can really see these packets don't degrade. And as a result of these engagements, the reporters, they were saying to me, well, cool, you've raised an issue. What's the solution? So I said, there's already an organisation who can recycle crisp packets. All Walkers and PepsiCo need to do is team up with this organisation and offer a collection scheme so people can collect and recycle their crisp packets. I threw them a lifeline. I told them what they need to do. Anyway, a few weeks later, I see this in the headlines: Walker's crisp packets recycling scheme announced. And then, a couple months later, Walker's launches recycling scheme after storm over crisp packets. They listened to exactly what I told them to do. And that just goes to show, if you approach something from a solutions-based approach, people will tend to listen. Nobody wants to be destroying the planet. If you can come up with collaborative solutions and they're feasible, a lot of the time you can have success. And since, this was first of its kind, nationwide scheme, millions of crisp packets have been recycled. And now, this year in the UK, you can recycle crisp packets from home. You can put them with your recycling, and the council will take them and recycle them. They are now recyclable. We've got what we wanted. And sure, I'm still finding old crisp packets on the beach, but we're finding less and less new crisp packets on the beach. And that's a real success story, I think. So that's all I've got to say. That's a summary of everything that I have done and continue to do. And really, I'd just like to say what I think you guys are doing, coming together to talk about the planet, is an amazing thing, because that is the most accessible and powerful thing we can do. So, just to end, I would like to thank you for inviting me to talk, but also for doing what you're doing. So, thank you very much, and I welcome any questions you might have.
Oh, thank you so much, Emily. Let me take you out of the spotlight one moment here. 1 second, remove spotlight. And let's have Najoti go first because she has not just a question, but something special. And Najoti, you should be able to share screen.
Yeah.
Oh,
Please
there we go.
accept the request, Lori.
Yep, there we go.
Is my screen is visible?
It's
Almost.
coming up. There you go.
Thank you so much. Great presentation.
Thank you very much.
I think, Emily, you have taken us into the different world. We all know this is common concept, and nobody like plastic. Everybody want to do something with the plastic, but you have represented a live example over here. The way you have carried this plastic and conveyed the message and implemented, as well as you have conveyed the message to the local community, not only local community, but at the top level to the responsible people. So this is our certificate of appreciation in recognition of your generous contribution as a guest speaker at Earth Talks, a weekly global dialogue hosted by Rotary Earth Network Club. So Emily, we are sincerely appreciating your contributions, and we really want you to, be a part of our club as well as become a Rotarian. You see, that will be our pleasure to be have you, as well as lot of things we can learn and do together. I'm an environmentalist. I'm master's in environment engineer. I do the laboratory analysis on water potable testing. We are having all the parameters related to the MPN, most probable number, that is a bacteria E. coli, and that analysis take care regularly for the whatever the community drinking water we receive. At the same time, we are having a pathogenic bacteria, that is a Shigella, Salmonella, and other kinds of bacteria that also we are actually analyze whenever there is a special requirement or request come from the community. So this is actually so much inspiring and very close to my work, whatever I do day to day. And I will put more efforts towards it. And in future, whatever possibility is there, with your collaboration, I will try to do more. Thank you. And we will go to our next speaker. Our next speaker is PDG Sabina Gartner Nishte. So she is going to tell us the same as today, very inspiring session. So next session will be more inspiring, same as today's session. That is a green belt borders separate, nature unites. So looking forward to you all. Let us meet next week, same time, and link will be shared. And Emily, I am going to share the overall email. I am going to send you the email with the certificate and everything, whatever the chats, appreciation, and some screenshots. Thank you. Thank you, Karen. Thank you, Laurie, for this opportunity.
Oh, Najodi, thank you for doing that. And for Emily, we do want to stay in contact. We have to figure out a way to make you, as Claudia said, was saying to me, like an ambassador to our club because we really appreciate you. And our first question is from Todd Fisher. He's one of the AGs in our club's district. Todd.
Thank you, Lori. Emily, I appreciate your presentation, very informative. You mentioned there was a goal by 2025 to have biodegradable or better earth-friendly crisp packets, potato chip packets. Did they meet that goal?
Hmm. Look. So how do I answer this properly? So technically, on a technicality, that goal has been met, because of the introduction of the scheme, the collection scheme, crisp packets could technically be recycled. So they said we will make 100% of our packaging recyclable, compostable, or biodegradable. So none of the packaging is compostable or biodegradable, but crisp packets can technically be recycled. So it is on a technicality, and they haven't changed a whole bunch about their packets, but they have invested in recycling infrastructure. So I will give them credit for that. And as I said, our local council and many other local councils around the UK will now recycle crisp packets. Our capability to recycle these materials is increasing. But in terms of the actual packaging design, it has not changed. So we are still working on it. We're still in consultation. There are crisp packets in the world that are compostable or biodegradable. The issue that we have, and to give the crisp manufacturers a break, is not just about their packaging, but our capacity to deal with biodegradable materials. Everyone thinks that biodegradable plastics are going to save us, but actually, to be able to get those packets to actually compost, you need an industrial composter, and there's only a few here in the UK. They're very, very rare. So the infrastructure is not ready to meet compostable or biodegradable packaging. So we really need better infrastructure as well as big multinationals to change their packaging. So we're halfway there.
Wow, thank you, Todd. Good question. Tamala, please tell us, do you have a question?
Yes, yes, thank you. And Emily, I just wanted to say that yes, your work, it was just so inspiring. And the fact that you're using art to promote awareness and get people to take action is absolutely fantastic. My question is though, given your research and the new research that's come out that is showing that physical and chemical recycled plastics intended for food, oral, or skinned application, um, that the introducing recycled plastic into them changes the surface morphology and elevated concentration of organic and inorganic chemicals, and in fact increases um, the chemicals such as metalloid concentrations over 10 times higher, PFAS concentrations twice as high, polyaromatics over 3 times as high, and there's other things. And it also, the plastic will get chemicals that weren't in the original plastic. So, given this new information, is your work on trying to get more recycled plastic in plastic, um, your goal, or is that changing?
I must say, what an elegant question. Thank you so much for contributing that. It was really fantastic, and you raised such an important point. So what makes plastic completely unique, and one of the actual benefits of using plastic is that we can add all kinds of different chemicals to plastics. Not many people know this. These are called plastic additives. And there's thousands and thousands of chemicals that can be added to plastics to make them flame retardant, but also as biocides to stop things growing on them, to make them more flexible, to make them stronger, and like colorants, lots of things we can add to plastics. And as a result, these chemicals can leach out and they end up in our food. One of some of the most concerning, as you said, are the PFAS, these forever chemicals, which we know have toxic effects on people, on wildlife. And that is one of the hazards of recycling, is if you're putting all of these different plastics together and melting them into new plastic, all of those chemical contaminants can be concentrated. So recycling is a good option, but it is not the gold standard. We cannot recycle our way out of this problem, and we should always go for reuse first or repurpose. I've always said the most sustainable thing is what you already own. We can't keep making new things, using new things, recycling new things because there are uh, associated hazards. So, to answer your question, recycling is not something I actively campaign for. It's something I encourage. You should recycle, but it is not going to solve the plastic pollution problem on its own.
Do do you think that in your work you'll find that there's more antibiotic resistant bacteria on a recycled plastic product, um, moving
Uh,
forward?
It's a very good question. Are you a scientist? It's very good thinking. Um, so what I'm now looking at is whether the chemicals we use in plastics are influencing the evolution of bacteria to make them more resistant. So we are finding that potentially these chemicals do encourage the evolution of bacteria. So you would think if a recycled plastic has more of these chemicals, you could get more drug-resistant bacteria. I haven't directly tested it, but it is a sound hypothesis. Yeah,
Thank you so much.
Wow.
thank you.
Thank you. Judith.
Okay, well, we're all shaking in our boots about now. So a question, it's well known that thin plastics are less stable and that they give off endocrine disrupting chemicals. And oh, I know what I wanted to tell you. You don't know this, but in the United States, there's an area down in Louisiana that is called Cancer Alley, and that is where petrochemicals are produced. And many Americans just call it a sacrifice zone. So, yeah. So it's not just, what once they're out in the world, they are hazardous at every point. So it's well known that, those little stupid plastic bottles that people put water in, that endocrine disrupting chemicals go into the water, and it's one of the primary drivers of our breast cancer epidemic. So I'm wondering if when they turn into microplastics, are they just as virulent in terms of carrying endocrine disrupting chemicals?
So again, fantastic contribution. Thank you. So there's two things here. One, um, when chemicals leach out of plastics, you always reach an equilibrium, right? So if you have a plastic bottle and it has chemicals in, then over time, those chemicals will leach into the water. And when the chemicals in the water are at the same concentration as the plastic, they're not going to leach too much anymore. So as a solid water bottle, at a point in time, you will plateau in the amount that leaches out. When they become microplastics, potentially those chemicals have already all leached out anyway. But my instinct is that as a microplastic, the sort of because the surface area is increased, the diffusion pathway is shorter, meaning it's easier for those chemicals to leach out. So I'm not entirely sure. I haven't researched that myself. I can't say that there would be more chemicals in them as a microplastic, but I'm thinking it might be easier for the chemicals to leach out as a microplastic. And of course, in the environment, you don't just have to worry about the additives, what's in the plastic already, but it's what attaches or absorbs to the plastic as an environmental pollutant, because there's so many chemicals already in the environment and plastics seem to act almost like a magnet for other chemicals. They just get absorbed to the microplastic and are carried around. So, yeah, that there's an associated risk as well of concentrating environmental pollutants. And then if that microplastic enters the food chain, then it can carry those pollutants as well.
Wow.
Thank you.
Emily, I know we're coming up to the top of the hour, but I would love to have you answer Raj's question. Can you stay a bit longer?
Yes, of course.
Oh, good, because Raj is like one of our favorite people. Just love Raj.
Thank you, Laurie. Emily, it's a really excellent presentation. You say you are not a young, I say you are a young lady and doing the excellent task.
Oh, I don't
So
feel
let
it in my back.
so let me ask you the question and few suggestions. In a plastisphere, you can have some microbes which will develop the ability to degrade the microorganism, degrade the plastic. Have you carried out any research in this direction? When they get in connection with they grow on the microplastic, over a period of time, they can develop a capacity to degrade the plastic. That's the one question. Second, you have done the excellent task as a beach guardian. My little bit statement may irritate some people. Anyone who are they are against the plastic. The plastic has saved the environment. It has reduced the cutting of the forest, degradation of forest. One, it has saved the metal. It's a part of our life now. As a person who are doing the beach guardian, can you ask the people, because plastic never gone to the water on its own, human has thrown into it. Can you carry out some projects as we are doing in my area? Can we carry out the projects where people will understand? Can we develop a guidelines to handle the plastic properly, so it will not go to the sea or it will not go to the water body? That's a one suggestion which I will like to have to one. The second one, as you see, the crisp plastic. Crisp plastic is recyclable. Now it is recyclable. You can make the briquettes out of it. You can make the refuse derived fuel out of it. And besides, you can again depolymerize. You can bring it to the original thing. Of course, it requires a cost incentive. So these are the things available. I'm very sure as the technology proceed, we will able to handle the plastic. My hats off to you. I love your Beach Guardian projects, and I really love because I love upcycling. So I'm really happy that you upcycle the plastic. Thank you very much. Excellent. All the best to you.
Thank you so much, thank you for your contribution. So I'm very, very pleased by your first question because I always like to end on that. So I'm coming back to your first question, but I'm gonna go out of order and go to your final question so I can end on your first question. In terms of having a framework to handle plastics, this is something that I'm working on at the moment. So worldwide, plastics are considered solid waste. They are at the same waste classification as garden chippings and food waste. That's how we classify plastics. They are solid waste. What I'm trying to do at the moment is reclassify at least microplastics, but hopefully all plastic pollution as hazardous waste, because the definition of hazardous waste is that it harms humans, animals, or the environment. Well, there's enough evidence now that plastic does harm at least one of those things, should be hazardous waste as a pollutant. Obviously, we can't say all plastics are hazardous waste because I probably couldn't wear the clothes that I'm wearing because there's plastic in everything, but plastic pollution should be defined as hazardous waste, which would mean that if there's a spill, you have to report it. If there's a spill, someone has to clean it. But at the minute, people were getting away with littering because plastic is not defined as hazardous. So that is what I would say about the framework of better handling of plastic. Crisp packets, yes, we are getting better at recycling. My dream is to have full circular economy so we can take a crisp packet and turn it into a crisp packet again. Why aren't we doing that? At the minute, we're taking a crisp
Great.
packet and turning it into benches. We don't need more benches. We need to be able to take a polymer and turn it into another polymer. And I see someone's just made a really good point in the chat that I forgot to make. I didn't tell my story that I always tell. And that is, of course, we have to turn off the plastic tap because doing beach cleans is forever mopping the floor and the tap is always going to be overfilling unless we turn it off. So we have to stop plastic at its source. But I'm going back to your first point now, which is my favorite. You said about the plastosphere, bacteria growing on plastics. Is there a solution here? Yes, there is. So, at the end of my PhD, I had two master's students. And we had this thinking, right? So I showed you my picture of these bags of waste that have sat at my location since 2017. And I'm thinking, there is no nutrient in these bags. It's just plastic. If there's any bacteria still alive in there, it has to be using plastic as a carbon source because how else will it be
Correct.
surviving? So I'm like, let's go mining in my waste for plastic degrading bacteria. And what we found is they're everywhere. There are bacteria everywhere that can eat plastic. It wasn't even just in the bags, but in the soil. Bacteria are amazing and they can just evolve the ability to handle anything, it seems. And plastic is not a very good nutrient source, but there are bacteria that can do this, and we can evolve them to make them better at eating plastic. So we're still working on it, but that's a solution that really is a solution. Taking plastic and converting it back into hydrogen and carbon, like that is
Yeah.
amazing. There is hope out there. We don't need to be shaking in our boots. I promise you, there is solutions coming. So thank you for your comments.
Erin.
Excellent.
Yes, I am so proud of you, Emily. I just adore you. I'll tell you. I'm so thankful too that you were able to make this talk happen. So, Emily works actually in Australia, and Australia is a difficult one for us to time, so other hemispheres. So she said, "Oh, I'm going to be in the UK during this period. Maybe we can do it then." So thank you, thank you, thank you, Emily. And Claudia, I want to thank you too, for bringing her to us. Yes, she's wonderful. And then Lori, definitely, Lori and the team, thank you so much for hosting today. You did great, and I just really appreciate it. But Emily, I just adore you. So thank you, thank
Thank
you.
you.
May I say only a word from Italy, Emily. It's fantastic to see such a young girl, because you are a young girl, being so active, so happy of her job, and congratulations. Keep going this way. All the best wishes.
Ah, grazie mille.
Prego, prego. And if you come to Italy, it's easy to reach me because Karen knows me and Lori too. So I am in Milan, waiting
Oh,
for you.
fantastic. I'll
Okay,
find you.
okay. Thank you, thank you.
And
Right.
Jody, yes.
Emily, just one query I'm having, even though I am also knowing the environment, but still, the plastic word is very favorite to everyone. So plastic actually, there is a replacement of plastic, but again, the name is only plastic. That is manufactured like eco-friendly plastic, we say, from the tree, from the bamboo. So are you thinking there is no plastic inside it or 100% biodegradable?
Um, Look, I am very skeptical about biodegradable plastics because it's caught me off guard a few times. When I first started, um, biodegradable plastic was quite a new thing, and I was like, wow, this is amazing. I'm going to tell everyone to use it. And I did. And then I found out that people were putting biodegradable plastics in normal recycling schemes. And of course, then it's contaminating the recycling and it's a minefield. And then actually, I'm like, will it actually biodegrade? Well, it won't if it ends up in the ocean. It needs very particular conditions. And so I am very skeptical about biodegradable plastics, but I do feel positive about the plastics that are being made out of seaweed. The plastics where you can literally eat them, and that's okay. So I think there is potential for it. I really do, but we really have to be careful because like I did, people might think this is fantastic. I will spend the extra money on these biodegradable plastics, but actually they just potentially more harm than good if they're not used in the right way. So, yeah.
Yeah, I think
Yeah.
community is getting, once they hear that this is a biodegradable, then they think there is no problem. We can carry on our own daily, whatever we are doing without following 6 hours. 6 hours first refuse. So they are just purchasing and then using it. So this is, I think, biodegradable plastic and plastic again. There is still more time to ban the
Yes.
plastic individually.
Yes. Yes.
Yeah. I think, and I would like to here mention one thing. My club member Lily is joined here. Welcome, Lily. Thank you so much for joining my club innovation UK. Claudia, our club
Oh,
member.
oh, Lily, you're muted.
Yeah,
Please say something,
yeah.
and then we go to
Um,
Arun.
And
yeah,
Arun Vadi is also there with
yeah.
the hand raise. Yes,
So,
Lily, please go ahead.
Emily, they do such wonderful things in Cornwall with the recycling. When you go to the tip, you are not allowed to put in a black bag. They open it up and they check everything, and that is the first community area that I have known do that.
And so there's no hiding anywhere. But I hope you can really beat the drum for labeling, because it's my big thing. I write to manufacturers all the time. They put false labeling on, and even when you try your best, you get fooled. So, and I asked this question just yesterday, and it's a world issue. We can't communicate on labeling. So, how can we communicate on any other level? Labeling is a big issue. And I always feel that the media and capitalism gets in the way. The only thing on the front of the label I want to see is what type of plastic is, and I have to go hunting for it. So please beat that drum. But thank you for your talk. It's so inspiring.
Thank you.
One thing I would like to share here, Lily and me and some members from our club, we actually initiated one committee we have formed, and we are giving for environment microloans. Yes, and already one loan passed.
Oh, fantastic. That's awesome.
Yes.
Arun, please.
Hello. Yeah. Two things. Yeah, I always say two things and end up with four, five things. But so there is this whole thing about collecting the very etymology of the word plastic. It's a magic substance that can be used for anything. But if you look into the etymology, plastic, by the English language definition, cannot go back to what it originally was. You have plastic ligaments, you have muscles, even in the human body. So, given that, and given human intervention in the terms of the common man collecting trash, segregating trash, and all that, and the multinationals or the corporates, or as some of us like to call them, the capitalists, just winding their way through the legalities of it, the base comes out in producing virgin plastic. So I'd like to deal with the the grassroots level of where the trash is and what it does, and what government policy and international directives can do to stem the rot that is already in place. So would you think that if you were to collect 25 tons of chip packets and put them in a place of PepsiCo or Coca-Cola, I come from an advertising background, so I'm pretty ruthless. So if you were to collect these and say, okay, we've got 25 tons of this that you produced, what can we do with this? And also levy a tax on virgin plastic and give a tax rebate on recycled plastic. Because money is king. At the end of the day, any insecure person, any person who wants to secure his future is going to look at how much money he can hoard to safeguard his future. So if there was a monetary ceiling on it saying virgin plastic will attract so much tax, recyclable plastic will get tax rebates. And you were to set up something, or we were to set up, it's typical human thing, no? You do it. We were to set up a collection center, collect 25 tons of it, and say, okay, ITC, okay, PepsiCo, okay, Coca-Cola, this is what you've produced. And we put in our sweat and blood and money and collected this. Now, what do we do with this? And we will push with the government to get you a tax rebate to fill this in, because this is a problem of scale. It is not my beloved beach or your beach or anyone else's beach. We're talking thousands of billions of metric tons. So if we were to go in for a policy action, what would you suggest we do?
Great contribution. Thank you so much. For me, so I think I've understood your question correctly. If there were 25 tons of waste in front of me, what do I think is the best way to handle that? What policy could we instill to ensure that? Well, something that really, other than exploring the concept of bacterial degradation of plastic, I think we need to find a way to actually get rid of the plastic because there's too much plastic on the planet. We need to find a way to get rid of it. As I said, we can't recycle our way out of it. Something that I am very, very excited by. Hopefully, you've seen there is somebody in the US who has created a machine. I'm not a chemist, I am a microbiologist. don't quite understand the chemistry, but he has developed an instrument that will literally turn plastic back into oil. He's calling it plasticine instead of gasoline. And you can literally put a load of rubbish into this machine and turn it back into oil. And I think that, for so many reasons, is just so exciting. Also a little bit terrifying, oil runs the world, what we're seeing at the moment in the Middle East. There's landfill sites everywhere. Are we all going to start mining for plastics to turn it into oil? I don't know, but that having a capacity to get rid of actually the plastic material, that's what I would want with 25 tons of waste, is to just find a way to completely get rid of it. And if it's not degrading it, using bacteria, turning it into oil, surely that's more sustainable, like a more sustainable source of oil than more drilling for raw fossil fuels.
Wow, thank you. Mark Hoppin is up, but Emily, if you ever wanted to join Rotary so that you could connect with all this, 1.4 million Rotarians around the world, we've got a deal for you that's perfect for people who are in the middle of their career. We want to connect you with Annalise Santini, who's on our board, also entrepreneur like you, making a huge difference. So anyway, shameless pitch. Shameless pitch. Mark.
Emily, what do you think about biodegradable garbage bags? I separate out my plastics, I separate out food waste, and it goes into a common bin. In many ways, I separate out my garbage, but what about plastic garbage bags? Yeah, not plastic, but biodegradable plastic.
Mm.
What do you think about those?
So I don't have a huge amount of experience with this. The only experience that I have is recently I bought a compost bin, and I'm provided with these biodegradable compost bags that I'm supposed to collect my compostable materials in and put that in my compost bin. And the bag is rubbish. It always breaks and it's just completely pointless. Um, I think we're a way off having sustainable but biodegradable materials. What I do have very fierce opinions on are biodegradable dog poo bags. Um, I don't know if you've seen these, but in the UK, they're everywhere. It's eco bags, eco poo bags, and all of these dog owners think they're doing the right thing, buying these biodegradable bags, and they scoop the poop and then tie the bag and hang it on a tree and leave it in the environment. And they think because it says biodegradable that it's the right thing to do, that it will naturally biodegrade. It doesn't. Of course it doesn't. It needs very specific conditions to do that. So I think greenwashing and labeling really comes in here with biodegradable bags. The one benefit that I know of with biodegradable plastics and biodegradable plastic bags is apparently they produce less methane when in landfill sites. So when plastic degrades in landfill sites, it produces a lot of methane, a very, very harmful greenhouse gas. But biodegradable plastics apparently produce less methane, so there's a benefit. Secondly, biodegradable plastics apparently burn hotter than fossil fuel based plastics. So if they're going into an incinerator, an energy from waste center, they could generate more energy. But yeah, I just think it's a very slippery slope with biodegradable plastics at the moment.
Thank you.
I was
Thank you.
noticing
Emily, I
Nishodi
would
who
like
works
to
on
just,
that.
Yeah.
And then we'll go to
yeah,
Raj.
Emily, actually related to the water parameter, IS standard we follow. In the IS standard, there are the chemical and biological parameters are there. With that should be under the limit for the community level. But still, I think we need to revise our standards with the microplastics also. If we add, then definitely there will be a great awareness, and government level that will be excellent work. But still, we are talking about the plastic, but it is not added into the standards.
Yeah. Yeah. Raj.
Maybe last question. No. uh, Emily, let me share a few things. In India, we have a resale value of plastic waste, and exclusively the milk bag in Pune. The We will call it to make and a scrap vendor. He collect at the rate of around 20 to 25 rupees kg. And then another rule we have, which is in India exclusively for plastic, that is called extended producer responsibility. It is the responsibility of the manufacturer to take the plastic. Of course, it is at the initial stage. One of the where I'm a consult in the corporate company, we are trying to implement that. So this is coming up. There are the good signs where the plastic, what you call pollution control will be there. So there are two things I want to share. Secondly, we talk about the biodegradable plastic. The biodegradable plastics are made of starch, protein, oil. These are three things are there. This is a high degree of polymerization. That's why they return and they gave a strength. They are well biodegradable. May take a longer time, but they are biodegradable. Exclusively, if the vermicomposting, what I observe, because I have some biodegradable plastics I put in the vermicomposting, it got degraded within 30 days. So they are made for the, because they are basically starch and the protein and the oil. That's all three things in that, which is the made it. So that's I want to share with you. An extended producer responsibility, which is coming up in India.
That's fantastic news. The extended producer responsibility scheme is being developed in India. I really hope you do a better job of it than the UK. It's not working very well here because the problem is, as you said, the producer should be responsible for the end of life of their materials as well as production and sale. And in that, they should be paying for recovery of waste and waste costs. However, in the UK, under the Extended Producer Responsibility Scheme, 90% of waste collection and disposal costs are paid for by the taxpayer. So we pay
Oh,
for it, not the producer. So you need to make sure that India does a better job than the UK.
Wow.
Already
That's
four official.
yeah.
Please go ahead, Maria.
Anna Maria. I know we need to let Emily go, but we love to connect. You're sharing these ideas all over the
We
planet.
can
Thank you. So can we do Anna Maria and then we'll let you go?
Sorry,
Thank you for your
we
it's
can have
patience.
it's
another
very
session.
late,
We can
but
have another session with Emily.
I have a question, not a question, an idea. Can Lori and Karin ask Emily to come another time to talk not for the plastic everyone is thinking about, I mean a bottle, a glass, and so on, but all the plastic is in the building where we live, in the cars that we use every day, because all the progress in every things that men are building, they are always problem. And now it seems they had the idea that is in Italian we say, I think in English is asbestos. There were
See.
so many people dying. And once I remember at the time of my parents and grandparents, seems to be the best solution to cover everything, and was really a disaster. So probably with plastic we do the same things with the building, because to make isolation, to make no soundproof something, and so on. So please, if you can talk also about this, because I think there's a big silence about this problem. And if you go to see an apartment, you look around, but you never ask about this, the building, about the material that I use, and so on. Probably it will take months to see you again, but I think if we want to know better our world, you can help us. Thank you.
It's a fantastic suggestion. Thank you. And it's funny actually, last year I went to a conference. It was a worldwide conference called Plastics 2026, a global symposium about plastics and human health. And somebody gave a presentation about all of the hidden plastics, and they said the one of the biggest sources is carpet in your home. So much of it's plastic. More plastic in carpets than plastic bottles or something like that. So, yes, I will come back if you will have me.
Oh my gosh. Emily, can you tell that we really love you? And I hope you love us too, keeping you all this extra time.
Thank you.
Yes,
Of course.
thank you. Thank you for your time.
It's a pleasure.
Yeah.
It really is a pleasure.
And your work, all the work you're doing. Now we have to, I was going to say, we can't keep calling her back though. We got to let her work and get this policies done and use her education to do good.
No, it's a
Claudia.
pleasure to see you.
Yes.
Yeah.
Claudia, do you want to close us out?
What can I tell more? Nobody speaks better than Emily does, so she's the greatest.
She is. She is.
Thank
you. I
so
you.
appreciate that.
much.
It's been a pleasure to meet you all, a pleasure to be connected, and I would love to continue talking. Karen has my email, but if you want to
Yeah.
contact me, it's simply Emily, EMILY, at beachguardian.co.uk. Just send me an email.
Yeah. Sweet. Thank you so
Thanks
much.
again.
Thank you.
And
Thank
Lily,
you,
thank you
Emily.
for
Thank you
joining.
for
Thank
everything
you.
you are doing.
Take
Thank
care,
Be well.
everyone.
Be well, Emily.
Bye-bye.
Thank
Bye-bye.
you.
Thank you, everyone.